When it comes to biosimilar insulins, what matters more? Proving they're similar enough or proving they can truly be trusted in real patients? Let's see what is about biosimilar insulins. Narrative review of the regulatory framework and registration studies. Since 2014, biosimilar insulins have been available in the European Union and United States. Despite these approvals, their commercial uptake has been limited. This is largely due to ongoing concerns among both physicians and patients regarding whether biosimilar insulins match the original reference products in terms of efficacy, safety, and quality. The European Medicines Agency defines a biosimilar as a biological medicine highly similar to approved reference product. Similarly, the US FDA defines biosimilars as products with no clinically meaningful differences from their reference medicines in terms of safety, purity, and effectiveness. The manufacturing of biosimilar insulin starts with isolating the insulin gene, which is inserted into host cells, typically bacteria like E. coli or yeast. These cells are then cultured and expanded to produce insulin. Following this, the insulin is isolated, purified, formulated, and finally packaged. From your point of view, what are the critical insights gained from recent biosimilar insulin approvals that could help enhance future global regulatory approval pathways? To confirm biosimilarity, regulators require comprehensive evidence covering function, purity, potency, and safety via 3 study types: analytical, preclinical, and clinical. Phase 1 clamp studies test pharmacokinetic and pharmacodynamic equivalence with sample sizes ranging from 30 to over 100 participants. For example, Innovator's glargine studies included nearly 300 subjects. Phase 3 trials evaluate efficacy and safety in larger populations, such as the abisaglar glargine trials with up to 1,291 patients over 24 weeks. These rigorous studies ensure biosimilars match their reference insulins in clinical performance. Unlike other biosimilars, biosimilar insulins do not require extensive long-term clinical efficacy trials because their safety and efficacy are established by the original product. HbA1c and similar endpoints lack sensitivity to detect meaningful differences. Instead, approval relies mainly on detailed preclinical and glucose clamp studies, with Phase 3 trials used mainly to assess immunogenicity when needed. A clear and science-based regulatory framework in Europe and the US ensures that biosimilar insulins match their reference products in safety and efficacy. This is achieved by demonstrating similar physicochemical properties and biological activity through preclinical and glucose clamp studies. As a result, both people with diabetes and prescribers can confidently use approved biosimilars without concerns. Data-driven assessment of basal insulin adherence in people with type 2 diabetes. A clinical data will be introduced in EASD Conference 2025. Adherence to basal insulin in people with type 2 diabetes remains a challenge. Recent data show adherence rates ranging from 74% to 78%, highlighting significant room for improvement to optimize glycemic control and outcomes.